So now we're using our trig ratios, okay? 53 degrees. Doing this first one, 45 and K. So there's our right triangle. It has to be a right triangle to use our trig ratios. It is. Okay, so when I'm using my trig ratios, remember that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. And you can remember these as SO, S-O-H, CA, C-A-H, TOA, T-O-A, or SOHCAHTOA. So my first job with any of these is to figure out which side I know and which I'm looking for and whether they're opposite, hypotenuse, or adjacent. 45, that's adjacent to my 53-degree angle. It's always from the perspective of the angle. So it's next to my 53-degree angle. And K is my hypotenuse. So I know that I'm working with adjacent and hypotenuse. It's going to lead me to cosine, unless I know that the cosine of a 53-degree angle will equal my adjacent side, 45 over K. Now I'm just solving for K. So now I have the cosine of 53 equals 45 over K. Remember, the shortcut is when you see these, you can switcheroo your K with your cosine 53. So it's K equals 45 divided by cosine 53. But if you forget that, you can remember that first you can multiply both sides by K because it eliminates these. And you're left with K times the cosine of 53 equals 45. Now to isolate K, you're going to divide by the cosine of 53. And I get K equals 45 divided by the cosine of 53. And yes, it is calculator time. Just pop over here. You go clear, clear. Oh, someone's at our door, bug. 45 divided by the that's times. We want divided by the cosine 53. You get 74.77. Okay, equals 24.77. And that's longer than our leg, so we didn't make a mistake. At least we know that. Okay, so now I'm going to do B. So I have a 34-degree angle in my right triangle. And I have a side of X and a side and a hypotenuse of 9. So first thing I do, just like before, I figure out what sides I'm working with. Our perspective is this 34-degree angle, so that's the opposite side. 9 is the hypotenuse. Opposite and hypotenuse tell me I'm using sine. So the sine of 34 will equal the opposite side X over 9. So when X is my numerator, I'm just going to multiply both sides by 9. And then I know that 9 times the sine of 34 equals X, because my 9s cancel. 9 times the sine of 34 equals X. Go to my calculator. 9 times, and when I just put the sign right next to the 9 on the right of it, that means it multiplying. Okay, if you want to put it on the other side, you can, but you need to close the parentheses. Sine 34 times 9 equals 5.03, which just rounds to the nearest tenth of 5. So our answer there is just 5. Rounds that way because we go to the 10th, 0. Look at the digit after it, 3. And since it's 4 or less, we keep the 0 the same. So 5.0 or 5. So that was B. Now C. It's going to be the same process. Okay, guys, we got a right triangle. We got a 25-degree angle. We got an X and a 44. So our 25-degree angle is that blue one. This is our ugly right triangle. So we first have to figure out what ratio we're using by figuring out the side we know and the side we're looking for. The side we're looking for is opposite our angle. And then we have the hypotenuse. So it's sine again. Sine of 44 will equal our opposite x. We're not sine of 44. What was our angle? Remember, it's the amount of degrees in the angle. 25. The sine of 25 equals x over 44. We're going to multiply both sides by 44 because we're multiplying by whatever's in our denominator. We get 44 times the sine of 25 equals x. We jump to our calculator. I'm going to go 44 times, by just putting, you can't, and don't worry, you can actually write times, if you want, 44 times the sine of 25. And that equals 18.595 or 18.6. So x equals 18.6. Now, that's C. It's not least D. Okay, a 37-degree angle, a 30-degree side leg, and a leg of x. So again, first thing I need to do is figure out what ratio to use by seeing what side I know and what I'm looking for. In this case, I know the opposite, and I'm looking for the adjacent. So it's going to be tan. So the tan of 37, tangent, will equal my opposite side, 30 divided by x. So now I could multiply both sides by x to get x tan 37 equals 30, then divide by tan 37, get x equals 30 divided by tan 37. Or I can remember that when x is the denominator in these problems, I can do the switcheroo. So x will equal 30 over tan 37. Now do 30 divided by tan 30 divided by tan 37. I get 39.81, which I round to 39.8. Boom. Okay, so that's x. So I'm now going to do these last two. Airport meteorologists. Okay, with these word problems, just remember, I'm just trying to get you to draw a right triangle. So airport meteorologists keep an eye on the weather to ensure the safety of airplanes. One thing they watch is the cloud ceiling. The cloud ceiling is the lowest altitude at which solid clouds are visible. If the cloud ceiling is too low, planes are not allowed to take off or land. One process a meteorologist can use to find the cloud ceiling at night is to shine a searchlight that is located a fixed distance from her office vertically into the clouds. Then she measures the angle from the office to the spot of light on the cloud. Okay, so we're just doing a right triangle here. It says, suppose the searchlight, and we can use this to tell us, is located 45 degrees from the office. 45 meters from the office, so that's 45. The angle to the spot of light on the cloud is 38 degrees. How high is the cloud ceiling? So anytime we've got something vertical and horizontal, we know it's a right triangle. We know this is 45 and this angle is 38. And we're looking for this vertical distance. So we've got a tan problem because we are looking for the opposite side and we know the adjacent. So that the tan of 38 would equal x, my opposite side, over 45. And now multiply both sides by 45, and I get 45 times the tangent of 38 is x. Let's find that bad boy up. So I go 45 times the tangent of 38, and I get 35.15 or 35.2 meters. Bum, bum, bum. That's it. No problem. Now, one more word problem, then we're done with our study guide. Okay, so physics, when an object travels at an angle, it's easier to break up the motion into a horizontal component and a vertical component. The principles of physics can then be applied to both directions. Suppose an object travels with a velocity of 25 meters a second. We got our hypotenuse because we're turning it into a vertical and horizontal at an angle of 40 degrees. So we got 40 degrees and the hypotenuse of 25. Find the horizontal and vertical components. So the only thing different here is I have an X and a Y. I'm looking for each of those. So you can do whichever one first. we'll start with x. Since that's opposite of my 40-degree angle and the hypotenuse, I know that it's the sine of 40 equals x, my opposite side, over 25. So 25 times the sine of 40 will equal x. That says 25 sine 40 is x. So 25 sine 40, and you get 16.069 or 16.1. So x is 16.1. And then y, for y, I'm now using the adjacent side right here in the hypotenuse, which is cosine. So the cosine of 40 will equal y over 25, my adjacent side over my hypotenuse. Multiply both sides by 25. Cancel out that 25, and I get 25 times the cosine of 40 y. Go to my calculator. 25 times the cosine of 40, and y is going to be 19.15 or 19.2, and I'm done with my study guide.